Hello and welcome to this lesson on solving equations with variables on both sides. So an equation with variables on both sides can kind of look like this one. You'll notice we now have an x on the left and an x on the right. The first thing that we should try to do is get all variables to the same side. Now later we'll do in the next lesson equations that have variables on both sides and also contain like terms and distribution, but for now we're not going to have that. So when you are moving all variables to one side, you are going to have to use addition or subtraction because you're going to have to make it cancel away on one side before you add or subtract it from the other. I recommend moving the smaller variable. This will reduce the number of negative numbers that you have to deal with. So to move the 3x over to the other side, I need to subtract it away so that it cancels out to be 0 on this side. And then over here, I have 2x left over. And then you bring down what's remaining. So that's that step. The second step is to realize that it's now a two-step equation, and I'm going to move the constant terms to the other side of the equation, I'm sorry. So because I moved my variables to the right, I want to move my constant numbers that don't have variables over to the left. So I'm going to subtract it so that it cancels away to be 0 on this side. Now I have 2x equals negative 5. And then the last step is to divide, because now we have a one-step equation, by the coefficient of the variable on both sides, and I get x equals negative 5 halves or negative 2.5. I'm just going to not 5 halves or x equals negative 2.5, either way. So that's solving an equation that has variables on both sides. Let's try another one, and this time we're going to check our results and practice that. Okay, so again, we're going to go back to our steps. We can see first we want to move all variables to one side and move the smaller one. So between the 5x and the negative 4x is smaller, so I'm going to add it to make it go away, which means I have to add it to this side as well. So I have 14 equals 9x plus 59. Now I have a two-step equation. I moved my variables to the right, so I need to move the 59 over to the left. And 14 minus 59 is negative 45. And then lastly, I'm going to divide by 9 on both sides and get x equals negative 5. Now, before I call that done, I'm going to need to check my answer. So when you check the answer, you rewrite the equation, but the answer that you got over here, the negative 5, is going to go everywhere there's an x on either side. So that means I am going to do negative 4 times that negative 5 plus 14 equals 5 times negative 5 plus the 59. Now remember, when we're solving, we don't do inverse operations. We plug in the answer we got and we just simplify each side following PEMDAS. So when I multiply this, that gives me 20, and 20 plus 14 is 34. This gives me negative 25. And if I do 59 plus negative 25, I get 34. So since the two sides were equal, it checks, which means my answer of negative 5 is the correct answer. All right, let's look at a typical word problem scenario where you will end up with a simple equation with variables on both sides. No like terms or distribution yet. That comes later. All right, so we have two businesses that are competing, and it looks like they are both electricians. One of them is called Zappy's, and it says Zappy's charges $55 per hour plus a flat fee of $75 for supplies. Okay. So I think I'll highlight that. All right, and then we have this other company called Bolts, which charges 60 per hour plus 40 for supplies. And the question says, for what number of hours do the two companies charge the same amount? What number of hours? That's what we're asked to find. And I'm going to use H to equal the number of hours that the job takes. And we want them to charge the same amount. So that means that the equation for Zappies is going to equal the equation for Bolts. So the charge for Zappies is going to equal the charge for Bolts. All right, so let's write the expressions for those. Zappies is 55 per hour, so that's going to be 55H plus that flat fee of $75. And Bolts, it says charges 60 per hour, so that's 60H plus 40 for supplies. So this is our equation we're going to solve. And using our steps from the previous page, I am going to move the smaller variable over to the opposite side. So it looks like this one is my smaller because 55 is smaller than 60. That cancels out. I have 75 equals 5H plus 40. I'm going to subtract 40 on each side, and I get 35 equals 5H. Dividing by 5 on each side tells me that they charge the same amount for 7 hours of work. Now, to check that answer, we could easily plug it back in. If I plug in a 7 here and a 7 here, on the left side, I will do 55 times 7 plus 75. I get $460. I should get the same amount if I do 60 times 7 plus 40. 60 times 7 is 420. I add 40, I get 460. So my answer of 7 does check. So if they both charge the same amount for 7 hours of work, then it stands to reason at certain times it's going to be more expensive to use the Zappies company. At certain times it's going to be more expensive. It depends on how many hours the job takes. This next part is an extension to this, which asks us when is one more expensive and when is one less expensive. We will revisit this situation later when we graph systems of linear equations, like two straight lines. But for now, we're going to do it by doing some numbers. So 7 is where the two companies both charge $460. So obviously, if there's a number less than 7, like maybe I'll put 5 in, and a number more than 7, so maybe I'll put 10 in, we're going to find out who's more expensive by plugging it in. So Zappies' expression is 55H plus 75. And Bolt's expression is 60H plus 40. All right. So I am going to now plug in my number that's less than 7. And my number that's more than 7, because I don't want to change colors right now. So 55 times 5 plus 75 gives me $350. Okay. 55 times 10 plus 75 gives me $625. So that's how much Zappies charges for these numbers of hours. Let's go do Bolts. 60 times, and I'm using 5 as the example. And I'm going to do 55. Oh, No, I'm sorry. I'm putting in 10 into 60 times 10 plus 40. Let's see what we get for these. 340. And 600 plus 40 is 640. So let's look at who's more expensive and when. We can see, because it's talking about more expensive, not less expensive. So I'm going to highlight the more expensive ones. They could ask you who's less expensive. So if it's less than 7 hours, for instance, 5, Zappy's is more expensive. If there are more than 10 hours, and I mean more than 7 hours, and let's say we're using 10 as an example of something that's more than 7, it looks like Bolts is more expensive. So this is going to happen whatever number we put in, like less than 7, I could put 6, I could put 2.5, I could put any number less than 7. So Zappy's is more expensive and Bolts is cheaper. Like right here, we're talking about right here, Zappy's is more expensive and Bolts is cheaper when there are less than 7 hours of work. Don't write the number 5 that you plugged in, because there are other numbers for which it's going to be also cheaper. So like it's going to happen no matter any number less than 7 you plug in. And then Bolts is more expensive and Zappy's is cheaper when you have a number more than 7 that you plugged in. So it could be 8, 9, 7.8, 7.5, 23 hours, whatever, any number more than 7. Okay, so that is the end of this lesson of just solving simple equations with variables on both sides. Join us for the next lesson, in which we are going to solve multi-step equations with variables on both sides and look at some examples of that.